Hi, welcome to the presentation of line 4 hazard modeling of the Ciclo project. I'm Gonzalo Montalva, and in this line we work with a large group of colleagues and students of different levels. I'll briefly show you what we have been doing so far. Our line is targeted with the mission of incorporating the results from research line 1, 2, 3, and 5 into useful products for the society and the engineering community in particular. So we're producing some engineering products, and we will put those into a geoportal where we'll have both tsunami hazards and ground level shaking hazards in both deterministic and probabilistic ways. Despite that, this information could also be used for other hazards such as landslides or liquefaction hazard modeling. The latter is already on the first draft of our geoportal, which should be up very soon for you to explore these preliminary results. So for the tsunami interaction, we have mainly relied on the work of Natalia Zamora and Ignacia Calisto. Both of them have worked extensively on tsunami modeling and now integrating probabilistic models for the entire Chilean coast so that we can have a tsunami hazard analysis incorporated into our analysis. For that, they're using the information from research line 1 regarding historical events, but also the segmentation that comes from research line 2. One of the important uncertainties that we have for the ground level shaking is the high frequency end of the spectrum, where we observe high uncertainty, high large residuals. These large residuals are being tackled by Diego Cárdenas using numerical modeling. So the near source events prove to have high uncertainty, either low or high residuals. And by incorporating the specific lithology of the site that comes up from research line 2 and the rupture process that comes from research line 5, he's aiming to model those in a more specific way, hence reducing the uncertainty that we have thus far in the modeling. Jose Drapela, another of our PhD students, is working on using the information from research line 5 that correlates the coseismic slip with the locking degree in the interseismic period to obtain better distance measures. This distance measure that we're testing is the distance to the asperity. So for this very simple model, we use either the slip or the locking degree. And we tested that for several of the already occurred large events, subduction events, Pisco, Tocopilla, Maule, Tohoku, Illapel, Iquique, and Pedernales. And in all of them, we observe a large reduction in total uncertainty, particularly in low periods or high frequency end of the predictions. So research line 2 and 3 provide us with the segmentation of the Chilean margin, but also with a map of the active faults that are known in Chile. Catalina Cabello, Carolina Peña, guided by Alicia Rivas, are turning those faults into seismic sources. In some cases, these seismic sources will be aerial because we don't know specifics of each of the faults. And in the cases where there's enough information, this will be single fault sources that all of them will be incorporated into our hazard analysis. There's significant more work on this to be done, but we're moving forward thanks to the advances in research line 3. Research line 1 is provided with the historical evidence, either that by history records themselves or using paleoseismology. For that, they have been doing tests in lakes and offshore, and this has provided with a long history of events. This is for the area of the 1960 event, which we have used for the proposal of time-dependent models, these recurrence models that consider the time of the last event as a good indicator of how soon we'll have the following event. This allow us to calibrate models such as the Brownian passage time or the Weibull models for the Chilean subduction zone. This is particular for the area of the 1960 event. We explore how improving the dating of the paleoseismic data would impact our predictions, how many events are necessary for have a reliable estimation. And of course, we provide the statistics for this method so that they can be used in future probabilistic seismic hazard analysis. We're currently doing the same analysis for other areas of the Chilean margin. For research line 2 has provided us with lithology, and we're using that to constrain site factors along, of course, with seismic records. We are doing several, we were following several aspects of this in order to constrain our side effects. One of them is using a Kappa model or studying the high frequency attenuation in Chile, the impedance contrast, shallow small strain damping, and provide computing physics-based synthetic records with all of that. I'll show you briefly the first two. The research by Ignacio Pozo, it's linking actually small strain with Kappa. He's following several avenues for that, but I'll show you here just the Anderson and Half approach, where for several stations, he computed the Kappa parameter, and with that, the Kappa naught and the Kappa R. So the Kappa naught can be related to side effects specifically, and of course to local site parameters, which we report in a paper that is forthcoming, and Kappa R that relates to path effects that also has significant results in the sense of the strong difference between interface and in-slab attenuation. Tiare Magallanes is working on impedance contrast. For that, she used a few stations where we have very well characterized shear wave velocity profiles, that's including the rock that underlies the sediments profile. So we have good characterization of the upper velocity structure, but also of the location and velocity of the rock. That allows us to compute impedance contrast properly. And for those stations, she proves that the high impedance contrast has a large residual, and the low impedance contrast a very low residual. That's despite the fact that current ground motion models do incorporate some of these parameters into their functional forms. However, there's still significant amount of uncertainty that is related to the impedance contrast, and hence a possibility to reduce our uncertainty in improving our predictions of hazard modelings if we know the surface geology properly. So all of this information will eventually go into our geoportal, and will continue to go in there as we produce it. The work that we're doing, it's ever evolving, so the sources information will go into the geoportal. The methods that we're using will also be there for the users to study and to use for their own studies. We'd like the geoportal to also be an educational platform. For that, we'll have some instructional videos on how to use everything that it's contained. Of course, the hazard models and the estimates, the user will be able to explore and to mimic some of the previous events that have happened in Chile. We'll have an advanced users platform or access, so that some people can download the data that we're using, or some of the data that we're using, and also will be allowed to upload some of their information, so that we transform the geoportal into a community portal, both for the scientific community and for the general public that will be interested on these topics. With that, I thank you very much for your attention, and I invite you to collaborate. If you're interested, please do not hesitate to contact us.